Hi, good morning, everyone.
Good morning.
So, we will start with a new topic that is networking. But before that, we will just quickly revise what we had discussed in the last session. So, we had discussed about IAM, that is Identity and Access Management, and we had seen what is the difference between identity and access. So, in identity, it is also called as authentication. Access, it is also called as authorization. So, what is the difference between identity and access? Is we had understood by a simple example, wherein we have the ID card and access card. ID card is a kind of an authentication, and access card is kind of an authorization. So it can be access card, or it can be your face, or it can be your thumb impression. So these are all methods of authorization, wherein there is some physical contact, wherein you can just authorize the information that has been stored in the backend database. So that is what authorization means. Even when we unlock our mobile phone using our face or using our thumbprint, that is also a method of authorization. Then we had seen, how we can create the IAM users, IAM groups, and how we can have the centralized access to our AWS account, and why IAM is required. What are the different features of IAM? That is what we had discussed. Then we had discussed, understood what is an MFA, that is multi-factor authenticator, and this is the same kind of OTP that gets generated in your mobile phone, and you can have an additional security on top of your AWS account. So we had also seen the practical how to enable the MFA. Then we had discussed about what is an IAM role and what is an IAM policy. And we had also previously in the yesterday practical, we had seen how to create an IAM role, IAM policy, and how to attach an EC2 instance with an S3 bucket. So this is the practical that we have done in the S3 module. Then we had discussed about IDP, that is identity providers. And after that, we had discussed about how then we had created a user with the name developer, and we had given the user different access. First we gave the user EC2 access, and he was not able to access other services, and later on we added the admin access, and this developer was able to access other services, right? So that is what we had seen, we had done practically, how we can give limited access to a single user, or how we can give entire access to a single user. So that we had done. We had done the practical, and for the same user, we had seen how to enable the MFA. So that also we had done, and I had suggested you to enable MFA for your account, so that it will get an additional security, because my previous accounts, they were there was some unauthorized access to my account, because the AWS is public, anybody can come and they can access your account. So it is better to enable the MFA for your root user. Okay, so just enable this MFA for the root user, so that you can have an additional security on top of your AWS account. So this is what we had seen. Now what we will see is, we will start with a new topic, that is networking basics. We will just understand the networking basics. Now the reason why we need to learn some basics of networking is because the next service that we are going to see, which is VPC. So VPC is kind of a networking service. Okay, so here we will be creating our private networks, we'll be creating the subnets, we will be creating the routing tables, we'll be creating the gateways, internet gateways, NAT gateways, and all these activities we'll be doing in VPC. So it is better that we have some basic understanding of networking. Then we will be alerting the private IP to the networking to the VPC, right? So we will be creating the VPC within the private network. So we should be aware what are the private IPs, what are the public IPs, what are the different IP types. So all these things we should be aware. And in NAT gateway, we'll be using something called as Elastic IP. Elastic IP, although we have already discussed it in EC2. We will still discuss it again over here. Then we need to understand what are ports, what are ephemeral ports, and all these uh, terms we should be aware before moving ahead to VPC. So that is the reason why we need to understand the basics of networking. So that is what we are going to discuss today. So let us understand, what do you mean by networking? So networking is nothing but connecting two or more devices to establish communication. So let's say I have a server and I have two more servers which may be in the within the same area. Let's say, for example, I am playing a game with my friends. Let's say I'm playing Counter Strike or some similar games which we play in a local area network. And for that, what we usually do, either we get connected to the same Wi-Fi, or we connect our laptops with a router, and we connect it with a Cat6 cable. So networking means to connect two or more devices to establish communication. So I'm connecting here multiple devices to establish communication. So either these devices are connected in this fashion, or they may be connected via a router or anything. But in simple terms, networking means connecting two or more devices to establish communication. Now, these devices can be any electronic devices. It's not only related to machines or servers. It can be any electronic devices. Even let's say if I'm connecting my mobile uh, through wired or through wireless communication, in whichever way I'm connecting my mobile phone as well, then that is also networking. So let's say if I'm able to send a message from my mobile to my laptop, then that means that like they have been networked, right? Somewhere it has been connected to each other. Maybe in a local network or maybe in a public network, but somewhere we are connected. So that is the reason I'm able to send a message to my laptop. Or let's say if I'm able to communicate with you now, okay, on this Google Meet, that is the reason of because of networking. Because somewhere your laptop, my laptop, we are connected together. Maybe not directly, but indirectly we are connected, right? Through the public internet, we are connected with each other, and that is the reason why we are able to establish communication. So that is the reason why I'm able to talk with you, and you are able to talk with me. So that is what networking is. So wherein you connect multiple devices to establish communication. So that is in simple terms what networking means. Now in networking there are some important components that we should be aware of. Although this is not something that will be asked in interview, but this is just for our information. What are the important networking components that we should be aware of before moving ahead with the other concepts of networking. So, what are the different important, rather, I would say, what are the important networking components? So, let's say this is my uh, machine, or let's say this is my laptop. Okay, so let's say this is my laptop, and this is your laptop, and we will just take an example that how are we, the example of our communication, and using the example, we will understand the networking components. So somewhere we have our router at our home. So I have connected my laptop with my router. You have connected your laptop with your router, and these routers have established the connection with the public internet, and this thing is done by the ISPs, that is internet service providers, maybe Airtel, Geo, or any other ISPs that you have in your area. So they provide the internet connectivity to the public internet. So this is how they are able to uh, provide the internet connection to the public internet. So this connection is done by the ISPs. Okay. So this connecting the router to the public internet, that is being done by the ISPs. That is called as internet service providers. Now let's say this is router, this is the internet, and this is your machine, and this is my machine. So let's say this is, let me call it as server 1, or let me call it as my server and your server. So let's say if I want to send a message from my server like this, how is this message sent, or how is this message received at your end? So what happens is my laptop will be connected with my router either wirelessly, okay, either I can connect it wirelessly, maybe through Wi-Fi, that is what is called as wireless, right? Wherein I'm connecting via the Wi-Fi, or there is alternate way wherein I can connect it via any cables. So I can connect it through cables as well, right? I can connect it using the Cat6 cables. In any ways, I am connected with my router, right? So let's say that I want to connect my router with my Cat6 cable, or let's say uh, uh, okay. So let me connect it using the cable. Okay, so this is my cable which is connected to my router. Okay, so I have connected my laptop with the router using a cable, and this cable I'll be inserting it inside the RJ45 jack, or what you can call in common language it is called as the Cat6 port, right? So that it will be connected to a Cat6 port. Now I cannot show that Cat6 port here. So this will be a port in your laptop, right? Wherein you insert the Cat6 cable. So I will be inserting that Cat6 cable to my laptop, and that behind that Cat6 cable will be the NIC card. So I've already explained you what is the NIC card, which is responsible for the networking, right? So this is what will be there, in the outside. Then this is something that will be visible outside, and behind this there will be a green colored card like this, right? Let me open it. Okay. So you can see here, this is the portion that will be visible outside. This is where you will be inserting your cable. Behind this will be a NIC card. So this NIC card that you can see over here, this is one of the important component of networking. Okay, so this, let me color this as blue. So this blue color part that you can see over here, this is one of the important component, that is the NIC card. Okay, and this card is responsible to give the networking to my laptop. If this NIC card was not present in my laptop, I would not be able to connect to the outside world. Okay, I will not be able to connect to the internet. I will not be able to connect my mobile with my laptop, or I will not be able to connect my laptop with another laptop. So this NIC card is important for networking. So one of the important components of networking is the NIC card. Now, second important component that you can see here is this. So this cable is also responsible for networking. Now this cable is called as the media. So through which media am I connected with my NIC card? Either this can be wired or it can be wireless. Even if I'm connecting my laptop uh, via the Wi-Fi, that will also it will also be let's say the networking will be done through this NIC card only. Even if I am connected with my Wi-Fi, this NIC card is only responsible to provide the Wi-Fi connection. Okay. So the second important component, as I told you, is the media through which the communication is established. So here the media is what we have taken an example is the wired. It can also be wireless. Okay, it can either be wired or it can be wireless. So this NIC card and this through this cable, this message will go to the router. Okay, this message that I have that I want to send it to you, this will be going through the router. Okay, and this let's say this message has gone here. Now this message needs to be again it will go to the internet, and when this message has been sent here, okay, so let's say this goes to the internet, okay. Now when this message goes to the internet is like a open marketplace, right? Anybody will be able to read the message or anybody will be able to access my information, right? Because this is anyways a public internet. Anybody can access this information. So there are some rules that needs to be followed, right? So the rules that needs to be followed is like let's say this message should be sent in an encrypted format. Okay, so the message should be encrypted. The communication should be secured. So the whatever communication happens between the router and the internet, it has to be secured. Okay, and it needs to go through a specific port, and all these things are called as protocols. So protocols in simple language are nothing but rules which needs to be followed while sending the message from the router to the public internet. Okay, so whenever this message that is been sent here, so this is my message. It needs to be secured, right? So this message that I'm sending, it needs to be secured. Nobody should be able to access that message on the public internet. So for that, there are some set of rules that needs to be followed. That the message should be encrypted. So let's say whenever you get a courier delivered from let's say Amazon or Flipkart, it is not delivered open, right? They will be packing it in some box. After that, they will be wrapping it and they will be pasting the sticker on the top of it, so that whoever comes to deliver your package, they should not be able to see what is there in it, right? They should not be able to see what is present in that package. So that is kind of an encryption, we can say. They are not able to open what is mentioned in your message, right? So or in your package, they can't access it. Similarly, whatever goes from the router to the internet, it should not be accessible by anyone. Okay, they should not have access to your messages. So for that, there are some set of rules that is required to be followed while communicating or while sending the messages from the router to the public internet. Now here comes the important part is if this communication is established via the HTTP protocol, then there are high chances that the attackers will be able to access your messages. Okay, if this communication is sent through via the HTTP protocol, HTTP is kind of a protocol, so it is kind of a rule that is followed in networking. And another protocol that I have told you is HTTPS, right? And we have already discussed the differences between HTTP and HTTPS. Now, whatever message sent that is been sent from here to the public internet, if that message is following the HTTP protocol, then there are high chances that this message can be easily accessed by anyone. Okay, because see, this is a public internet. Anybody can read this message because this is an HTTP protocol. It's kind of HTTP is like you are sending something openly. You are not sending it in some envelope and all. You are just let's say, writing a letter, and you are just giving it, hand to hand to the postman, and please deliver it to this guy. So you have not, you have not enclosed it in some envelope and all. You have just given an open letter to the postman, and you have told that postman and just go and deliver it to my friend. The postman can easily read the letter because it is open. It is not wrapped, it is not enclosed. So this HTTP is similar to that. HTTP is like, sending open messages on the public internet, wherein anybody on the internet can read your messages, or they can read your information, or they can read your data. So that is what HTTP protocol means. Anybody on the internet, they can access your information that is available on your website. So that is the reason why HTTPS protocol is preferred always, because HTTPS protocol, what happens is, additional certificate is attached on top of HTTP. So what happens in HTTP and HTTPS is, let me just take a diversion here. So what happens, the difference between HTTP and HTTPS is that additional certificate will be attached. Okay, so HTTP along with a certificate. So there will be a certificate that will be attached along with HTTP, and that is what makes an HTTPS. Okay, so HTTP plus a certificate is equal to HTTPS in simple words. Okay, so when you provide a certificate on top of HTTP, okay, that certificate, then your website will become HTTPS. Now, who provides the certificate? Now, this certificate is provided by third-party organizations. Okay, so this is provided by third-party organizations, and they give a certificate with a validity of 6 months or 1 year. So after specific period, or after 6 months, or after every year, you need to renew the certificate. Now, how to view the certificate? Now, let's say this website that I have is also secured. You can see here the connection is secured. If I click on about this page over here, not here, sorry. If I click on this, and if I click on this, connection is secured, this part over here, and if you see this is showing that certificate is valid. You can see here there is a certificate that has been shown over here. Now, who has issued the certificate? It has issued by this uh, organization, which is not mentioned here, but it is a common name, that is art and something. So I think the organization name is Let's Encrypt. So this is the name of the organization. The certificate was issued recently on 4th of November, and it is valid till February 25, 2025. So 3-4 months, that is the validity of the certificate. After 4 months, this particular website, it needs to renew its certificate. This is the certificate, this is the key, and all this information is available here, right? So this is how you can view the details of the certificate, right? So who is the issuer and all, everything will be available over here. So there are third-party organizations, mostly, uh, which are responsible to provide the certificate. Now, do we have any service in AWS wherein we can get certificate? The answer is yes. We have something called as Amazon or AWS Certificate Manager. Okay, we do have a service which is called as AWS Certificate Manager. In short, it is written as ACM, which provides such certificates. So in AWS also, you have some service. So they will contact the third party organization, and they will arrange the certificate and all. So that is what ACM does. Okay, so this is the difference between HTTP and HTTPS. So let's come back to our topic. So the third important component in networking is the protocol. So protocol is nothing but the rules that are used to establish the communication on the public internet. So this is just a rule that I have mentioned here. Here, the full form of HTTP means Hypertext Transfer Protocol. So it is also a protocol. Even SSH is a protocol, RDP is a protocol, DNS is a protocol. So whatever ports that we use, they can be called as protocols. So what are some important protocols that we have already discussed? That is SSH is a protocol, right? So we will be connecting to the remote machines via the SSH protocol. That is also kind of a rule. SSH is a protocol. HTTP is a protocol. HTTPS is a protocol. RDP is a protocol. DNS is a protocol. SMTP is a protocol. STP is a protocol, and all these are all called as protocols only. Here you can see here RDP means remote desktop protocol. SSH is also a protocol. So what is a protocol? Protocol is nothing but the rules that are used to establish the communication, okay, on the internet, right? So these are the rules that are followed when you are establishing a communication on the internet. So this is what a protocol means. So the first important component that I told you is a NIC card. This one. Second component is the media. Third important component are the protocols. Okay. So after this, what happens is this message again it will be going in a secured manner. Let's say we have used HTTPS protocol, and this message will connect to the router. So in the backend, there are multiple things that happens. How the DNS is resolved that we will be discussing in more detail later on. But just as an overview, so it is internet. It will go back to your router. It will fetch your router, and this router will again it will send the message to your. Let's say you have connected your laptop to this router, and this will be connected via the NIC card. Right? That is what we have already discussed. And then you will receive the message that I have sent to your machine, right? Okay. So we have discussed about NIC card, we have discussed about media, we have discussed about protocol. Now this internet will fetch your router via the IP address. It's like if I want to call you, I will be needing your mobile number. Similarly, if the internet wants to reach you, it will be reaching via the IP address. So it is a unique number that will be given to your device. So let's say your router will be given an unique IP address. So this internet will be able to communicate to the router via the public address. So let's say you have the address to your router like this 11.12.13.14. So this is let's say a public IP. So what this internet will do is it will reach to your router via this IP. Okay. So it will reach to your router via the IP, and that is where the fourth important component of networking is, that is an IP address. Now, what are the different types of IPs, and what is this number exactly? Like what is this number called? We will discuss this also in detail, but let me just finish up the important components of networking. So the fourth important component is the IP address. So the reason why the internet is able to reach to your router is because of the IP address. Okay, so it knows your number. Now let's say if I want to call you, I will be needing your mobile number. Similarly, if this internet wants to send this message to your router, it will be needing your number. Okay. So it will get your number, it will send the message here, and from here the message will get delivered on your machine. Now, there is another important component that is called as the topology. Topology simply means the arrangement of how the devices are arranged or how these devices are connected with each other. Right? So here, this I have just shown you a one-to-one connection wherein I've connected my router to the laptop, But let us understand more about topology in detail. So another important component, the fifth important component of networking is topology. Topology is nothing but the arrangement of devices, and that also plays an important role in networking. So topology is nothing but it is how the devices are connected with each other. Either they are connected end to end or they are connected via a medium. So that also plays a very important role. That is what we call as a topology. So let us understand topology and IP address in more detail. So this NIC card we have understood, media we have understood, protocols we have understood, and we need to deep dive and understand IP address and topology. Okay. So before understanding the IP addresses, let's understand what is a topology. So topology is nothing but it is the arrangement of devices or how the devices are connected to each other. Now again, this is not important from the interview perspective. Nobody will ask you to explain the topology, but this is just simply that you should be aware how the devices are connected to each other. Let's say there are two devices. I've connected them like this. This is called as end-to-end connection, wherein one device is connected to or it is connected with the other device end-to-end, right? It is connected, uh, end-to-end. So, it will establish the communication. In case if this connection breaks, then there are high chances that the networking will break, right? Because the connection has broken. Now they won't be able to establish the communication. Okay, so this is kind of called as an end-to-end connection that we have in topology. Okay, so this is what we call as end-to-end connection. Now, what are the limitations of end-to-end? End-to-end are connected just one-to-one. So if there is if the cable breaks, then the communication will also break. So let's say I've connected my laptop with my friend's laptop, and if there is some problem with the cable, then I will not be able to connect to his laptop, right? So you may have faced this connection issue. That we usually do is end-to-end. One machine is connected to another machine. This is called as end-to-end connection. Another connection that is there is called as a ring connection. Now, again, I'm telling you, this is just for your information. You don't need to worry. Even if you don't need to focus on this. This is just for your information how these connections are made. So this is the another connection that we have. This is called as a ring connection. So they are connected end to end, but in a ring format. Okay, so again they are connected end to end, but again the limitation is that let's say if one of the this breaks, okay, or let's say it breaks like this, then this particular device will get isolated. Although other machines they will be able to establish the communication because they are connected in a ring format. So these machines they will be able to establish communication, but one of the machine will become isolated. So it will not be able to communicate with these machines. But these four machines they are still able to communicate. Even if the cable has broken over here, this machine over here it can communicate to this machine from this route, right? From this medium. So that is what is called as a ring connection. Right? So they are connected in ring, but if in case if this breaks, then the communication will break. So if you don't want this, you don't want that this communication should break for this device, there is another uh, connection or another topology that is used that is called as a star topology. Now what is a star topology? These devices are not connected like this, but they use a common medium, or let's say a common device, to connect with each other. So instead of this, they will have a common device like this. Maybe you can take an example of a router, right? So they will be connected commonly via a router or any other device like this. And this connection is called as a star connection, wherein even if this connection breaks, or let's say they are connected in a star network, but again there is a limitation that if this connection breaks, this will get isolated. So this is again a limitation. This is another type of we can say what you call a topology that is used. But again, there is a limitation. If this breaks, then this will get isolated from other network. So there is another connection which is a combination of ring and star, and that is called as a mesh. So this is a combination of ring and star, and that connection is called as a mesh. So what happens in mesh is that you will have this, along with this, you will have a common device, and they will be connected like this. So now this provides high availability. Even if one of the connection breaks, you still have connection from other way like this. So even let's say if one of the cable breaks here, the device, this device will still be able to communicate via other way. Right? There is another way it can connect. It has connected through three ways. Right? Even if this breaks, it can still communicate. Okay, so this will not get isolated until and unless this breaks altogether. All the three routes should break. After that, only it will become isolated. So this is much more secure, and or let's say it provides high availability. Even if there is a break in the connection, it can still connect with the devices. And another type of connection that is called as a bus connection. And this is how the devices are arranged in this format, and they're just connected like this. This is called a bus. So this is the these are these are the topologies that is used in networking. So these are the different topologies used in networking. Now let's understand and more about IP address. Let's deep dive and understand IP addresses. And before the IP addresses, we have already discussed what are ports. Right? Ports are used, to define the protocols. Right? So whatever protocols are defined, they are defined as the ports. And what is a port? I have already explained you. I had given you example of a mall. Right? So wherein there will be different gates for different people. So let's say this is the gate for the customers. This is the gate for the employees. This is the two-wheeler gate. Let's say this is a four-wheeler gate. This is the ambulance gate. This is the emergency gate, and there will be several other gates, right, in a mall. Similarly, in a server, there will be different gates. These gates are called as ports, and there are around 65,536 numbers of ports in a server. Although not everything are opened, you can open them as per your requirement. But there are around 65,536 ports that are available in any server. Now the important ports I have already explained you previously, that we have the SSH port that works on port number 22. Then we have the RDP port, which is used for connecting Windows machines, that is 3389. Then we have the DNS port, which works on port number 53. Then we have, let's say, HTTP port, which works on port number 80. Then we have the HTTPS port, which works on port number 443. Then we have another port, that is STP port, that is port number 25, and so on. So these are some important ports that are used in any servers, right? And we had also discussed about this port. I don't remember the name. Uh, NFS port. I mean, I don't remember the port number. I think it is 2089. But we had used this NFS port also, right? We had also done the practical for the NFS port. So these are what ports are, right? So whenever there is any communication that needs to happen to your server, it can be communicated, or it happens through multiple ports. So let's say if you're using insecure websites, or websites that are not secured, it will be communicating via the HTTP. Let's say you want to connect your local laptop with your virtual machine, or let's say with your EC2 instance. So that will be using the SSH port. So we had connected our laptop with the EC2 instance, right? So this is, let's say, my EC2 instance. If I want to connect my laptop with my EC2 instance, then that will be done via the SSH port. So let's say, if somebody wants to connect to your machine, or your machine wants to connect to the public, so that will be done via the HTTP port. RDP port is similar to this SSH port, but this will be used for Windows. SSH is used for Linux, right? So this is what we have discussed. So this RDP port, again, it will be used to connect your machine with your server. So if it is a Windows server, then you will be using this port number 3389, that is RDP port. And if it is a Linux, then you will be using port number 22, that is SSH port. Now DNS is wherein you can give the domain name. Let's say you are using example.com. So if you want to use the domain name and you want to get the domain name result, for that you will be needing to use this port number 53. That is what DNS port is. So we will be understanding about DNS port, or let's say what is 50, we will be discussing about 53 port in more detail later. And let's say HTTP is again used to establish the communication, or it is used to connect to the uh, web servers. So that is what HTTPS port is. But this will be secured. So this is moreover insecure, and this communication happens with a secured fashion, right? So this is something that we should be aware, that these are the ports and how these ports function in a server, right? So there are around 65,536 ports, and we have discussed some important ports within a server, right? So that is what a port is. So port is an interface between the computer and other devices. So wherein you can connect your external devices to your computer. So this These are the physical ports that are visible in your laptop. So you may have seen this port, that is the RG45 port. Then you may have seen this HDMI port. So this is the Type C port. Then you have this another VGA port, right? And there are seen this is the micro port, right? So these are the ports that are also visible in your laptop, right? You may have seen these ports. These are the physical ports. And what I've shown here, these are the virtual ports. So these are, anyways, that is same only. Okay, so they are used to provide connectivity. Okay. So as I told you, port is like a door to the server. So from there you will be able to access the servers and all. And these are the some important ports that have been mentioned here. Now there is in these ports there are some special ports that are called as ephemeral ports. And the range of ephemeral ports is 1000 to 65,536. Yes, correct. So ephemeral ports, these are the ports that are from range 1000 to 65,536. Now, what is the purpose of ephemeral ports? Now, the purpose of ephemeral port is, let's say, in case if any of the port becomes unavailable. So, let's say if any of the port will become unavailable, they will provide some temporary port from this any of this number. So from 1000 to 65,536, any other number will be provided here. So let's say, for example, my HTTP port is not working uh, temporarily. Let's say my HTTP port is not working temporarily. What ephemeral port will do is it will give you another port, let's say port number 8080, just for temporary communication. Once this HTTP port is back, once the HTTP port is available, this 8080 will get deleted. It will not be used. So ephemeral ports are kind of temporary ports that are used to replace the actual ports in case if they are not working. Now these ephemeral ports are used at the VPC level, wherein you want to provide some temporary access to different ports. Okay. So these ports we will be using in VPC, mostly in NACL, wherein we will be providing the giving the access to our subnets and all. So this we will be discussing in more detail. But just remember that ephemeral ports we will be using for NACL. We will be needing to keep these ephemeral ports open at NACL level. If you don't keep this open, then there are high chances that we may not be able to establish the communication. So this is very important. These ports are important from the NACL perspective. Okay, and these ports we need to keep them open so that in case if any of the ports become unavailable, these ephemeral ports can come into picture and they can give us some temporary ports for temporary time period. Okay, so they will just give the access for temporary time period. So this is what we call it as ephemeral ports. Okay. And this is the range. Just remember this range. So it is from 1000 till the last port number. Now, as I let's come back to IP address topic. So we were still discussing IP address. So IP addresses they will be communicating via the port only. So I need the number, I need the number, and I need a device, right? So from where I can communicate it with you. So the IP address will be needing different other ports, and they will be establishing the communication. Now IP address are basically categorized into two kinds. One is a public IP, another is a private IP. So you may have seen this when we were doing the practical of EC2. And this in this also we have IPv4 and IPv6. So public IP can be of IPv4. They can also be of IPv6. Same is the case with private IP as well. So there are two categories of IPs. We have the public IP and private IPs. And furthermore, they can either be IPv4. So your public IP can either be IPv4 public IP or IPv6 public IP. Same is the case with private IP as well. They can be either IPv4 or IPv6. Now, what is IPv4 or and what is IPv6? Now, first of all, let us understand what is an IP. IP means Internet Protocol. Right? So these are the rules that are used at the internet level. So that is what IP means, Internet Protocol. Okay. So Internet rules that is used, and that is what IP is. And IP address is a number. Okay. So there is a difference between IP and IP address. IP is Internet Protocol. IP address means a number. So public IP, as I told you, it is furthermore categorized into IPv4 and IPv6, right? And again, we have the private IP, IPv4 and IPv6. But what is the difference between IPv4 and IPv6? First, we will discuss that, and then we will discuss the difference between public IP and private IP. Now, what is the difference between IPv4 and IPv6? So, IPv4, as the number says, it has four blocks of numbers. For example, as I told you, it's like this. Okay, so there are the four blocks. Okay, and each block that you have over here is of 8 bit. Okay, so this single block is of 8 bit. So it will have 8 bit of information, and so the total 8 multiplied by 4 will be equal to 32 bit. Okay, so IPv4 will be 32 bit number, and this is how the number will look like. Okay, this is how the number will look like. The number starts from this number, that is, which is accessible to all, and it ends with this number. Okay, now you can just notice here something. You can just notice something, that if you are talking about this range, so from 0 to 256 dot 256 dot 256 dot 256, you can see, if we just calculate the number, the total numbers that can be formed from this combination is very limited. Okay, and it is in some few crores. Okay, so this IPv4 that you have is a limited range of numbers. Okay, so it is having a limited range of numbers, and that is the reason why you may have noticed, if you restart your laptop or if you restart your EC2 instances, then the IP address will keep on changing. So this IP address will get changed, or it will get allotted to some other device. And the reason why IPv4 keeps on changing is because it is limited. It has a limited range of numbers. So you can see here, from 0000 to 256 IP addresses, there are, the combination of these numbers are very limited, and that is the reason why IP address, it is, very, it is not constant. So the moment you restart your laptop, or if you restart your EC2 instance, that we are also seeing, then the IP address will change, right? So the IP address will keep on changing, and this is the reason why, because it has a limited scope, it has a limited scalability. It cannot go beyond a limited range of numbers. So that is the reason why IPv4 keeps on changing. Okay, because the numbers are limited, and because of this limitation, IPv6 was introduced. So IPv6 is more advanced IP address. So it will have, instead of four blocks, it will have six blocks of code, and each block will be of 16 bit. Okay, so it will be like this, something like this. Let me just show you simple IP IPv6 address example. So let me take this example. Okay, so this is how an IPv6 will look like. And you can see here it can scale, or it is not having a limited number. It has several numbers. Now you can see here 1, 2, 3, 4, 5, 6, and 7. It should not be 7 once again. Let me take this example. So you can see here there are 6 blocks of code, and they are not only numbers, they are combination of numbers and alphabets. Okay, so this is how they will be in combination with. Okay, so it will be in combination of numbers and alphabets, and they will be of total 6 blocks. Okay, so they will be around of total 6 blocks, and this IPv6 that we have is 4 times of IPv4. So it is around 32 into 4, that is 128. Okay, so IPv6 is of 128 bit of information, and IPv4 is of 32 bit, and this is how a typical IPv6 will look like. This is just for your information. This is how a IPv6 will look like. You can also see the IPv6 in your EC2 instance, but this is not yet familiar, or it is not used commonly. Okay, so whenever there is some special IPs that are required, then you will be using the IPv6. But IPv4 is something that is used commonly. That is what we are already aware of. Then what is the difference between public IP and private IP? So public IP, by the name itself, you can like understand that public IP is something that is accessible publicly. Anybody from the internet, they can access your IP. That is what a public IP is. And private IP is something that is used internally. So it will not be uh, accessible to the outside world. So anybody from outside, they will not be able to access your private IP. But private IP will be accessible internally. Okay, so within your internal team, so it will be accessible to them. Let's say if I'm playing a game with my friends, and if I'm connected, in a local area network, that is kind of a private IP. It will be connected via private IP. So this is a group of people, or let's say internal team, and only they can access the private IP. Or let's say internal servers. Okay, within your network, if you have your own, so one server which is in your same network is able to connect to the other server via private in network. Okay, you don't want to go to the internet for that. You don't want to, you don't need to reach. So let's say this is my server, and in the same premises I have another server, or let's say I have 3 servers like this. And let's say if I want to do the networking, why do I need to go to the public internet? I can just do it locally, right? I can just connect them internally in a private network. They can establish a communication. So this is called as a private IP. So they will be connected via private IP. So the examples of private IP that you may have, common example is 192.128.0.0. Let's say, for example, this is the common private IP that is used. Another private IPs that are used is 172. Uh, 172 dot something is there, 0.0.0, and then 10.0.0.0. So these are some common examples of private IPs that are used. So if you are using them internally within your network, you don't need to reach to the public internet. This is some example of the private IP. Okay, 172.16 it will be. It can also be 172.32. So that is the range. So from 172 to 172 dot 32 dot 0 dot 0. Let me just cross check it. It will be till 31 only. And this will be from 128.255.255. Sorry, 168. And this will be from range 10 to 10 dot 255 dot 255 dot 255. So I'm just telling you the range. So it will start from this, it will end at this. These are some private IPs. So if you want to connect something internally within your network, it will be connected via private network only. So let's say if I'm connecting my laptop with my friend's laptop at my home, I don't need to go reach to the internet for that. Okay, I can connect it internally and it will be more secured. Nobody else will be able to interfere in our network because we are connected privately. Okay, so that is what a private IP is, wherein you can use it either to connect it to the internal team or it can be used to establish communication internally. So we will create servers and we will try to access it from outside, and we will also try to access one server with another server internally. So we will see that also. We will do that practical as well in VPC. Okay, so we will try to connect servers within the network. We will try to establish the communication. That will happen. If we try to access that server from the outside world, it will not happen. Although, or rather, you will not get the public IP only. They will not expose their public IP. You can't reach them. Okay, so let's say if you don't give me a phone number, I cannot reach you. Similar way, they won't have any public IP only, and ultimately nobody can reach them. So that is what a private IP is. Okay, it will be not exposed publicly. It will be moreover in the private network, and nobody can reach them. Now this is the table that you can use to refer the different private IPs and public IPs. So the simple thumb rule is this ABC that you can see. This is the private IP. Just remember this private IP. Anything outside this is a public IP. Simple logic. Okay. Anything outside this is a public IP. If anything comes within this range, that is a private IP. So this range that you can see here, this is a private IP. Anything outside it is a public IP. Okay, so you just remember these range 110.10 and 170 to 192. Anything outside this is a public IP. Okay, that is what I have shown in the table. Now, what are the different IP classes that we should be aware of? So one, we have the class A, then we have class B, then we have class C, then we have the reserved, a multicast and reserved. Okay, so in this we have the private IP, then we have the public IP. In class A, I have already told you the public IP that is in the range of 10.0.0.0 to 10.255.255.255. Anything outside this is a public IP. So public IP will start from 0.0.0.0 to 171.255.255.255. So this is the public IP because this is outside the range. In the class B, we have 172.16.0.0 to 172.32 or 31.255.255, and anything outside this, that is 173.0.0.0 to 191.255.255.255, that is a public IP. So it is easy to understand because I am aware of the uh, private IP, right? Then after this, we will be having 193, I guess. Let me check. Sorry, my bad. There will not be any private IP in class D. That is something class C. Okay, so the private IP will be 192.168.0.0 to 192.168.255.255. That will be IP, and after this it will start from 193.0.0.0 to 255.255.255.255 to 23. Okay, so this is the class ABC that is used uh, commonly. Okay, so you can see here class ABC is something that is open to the public. Okay, and they can use this IP from class ABC. Now, this class D and class E that you can see here, these are some special IPs and they are not open to the public. Okay, so this will be used by special, we can say, organizations like government or agencies and other confident or let's say uh, high secret agencies and all. Okay, so these other public IPs that you can see here after this class ABC, they are not exposed publicly. Okay, so they are not available to the public use, and that is what we have class D and class E. Okay, so in this we don't have any private IPs, so there are no private IPs here. But here you have the range from 224.0.0.0. So that is the range it will start. And here again in the reserved we don't have any private IPs, but again it will start from 240 to last number. So from 240 dot 0.0.0 to the last number, that is 255.255.255.255. That is the last IP that we have, and that will come under the reserved class. So that reserved class is reserved for the special agencies, and multicast will be used for other communications. Okay, so these are the IP classes that we have. So the simple thing is just remember these IPs and you are good to go. You don't need to remember everything. Just remember the private IPs. Anything outside this private IP will be a public IP. Okay, so the thumb rule is just remember this. You don't need to remember class D and class E. So we have 000 pins which is open to all. IP address 127 to 127.255, which you cannot find it over here. Okay, so there is no 127 here. Okay, here I made a mistake. Anyways, IP address that is 127 is not visible in the table, and that is reserved for loopback address, okay, which is used for app and networking testing. Okay, so that 127 is a special IP which is reserved for networking and application testing. Now VPC has 16/16 CIDR, and what is a CIDR? We will just understand. Okay, so as I told you, VPC will be having the CIDR blocks. So VPC will have the CIDR block from slash 16 to slash 32. Now, what is a CIDR? Or you can also call it as CIDR. what do we mean by CIDR? CIDR means classless interdomain range. Okay, so that is what class CIDR means. It is called as a classless interdomain range. Now, how can you calculate and why do we need this CIDR? So I told you IP addresses are limited. So let me take an example of 10.0.0.0. So this IP is a single IP. Okay. Now, if I want to use my uh, private network, I want multiple IPs. I cannot just rely on a simple range of IPs. I can subdivide this further. Okay, I can divide this IP further into multiple other IPs. I can divide it further into 65,536 IPs. Okay, I can further divide a single IP. Okay, so I can further divide it into, or let's say I can just divide it into multiple different IPs, and maximum range is 65,536 different IPs, and that term or that method is called as CIDR, wherein I am dividing this IP into further more IPs. So how do I divide it? I just add a slash 16. So if I add a slash 16, I will get 65,536 further IPs. And how are these IPs started? It will start from 10.0.0.0 like this to 10.255.255.255. Okay, so this is the range that will get further divided into this range. And if you just calculate this IP, it will be around 65,536. Now there is one calculation that is followed to calculate the CIDR. So how did I calculate the 65,536? Let me just show you. So the number of IPs will be these many IPs. Okay, I will get these many IPs from this single block. Okay. Now how do we calculate the number of IPs? How many IPs from CIDR? Okay, how do we calculate the number of IPs? There is a simple formula that is used, that is 2 to the power 32 minus x. Now here x is the CIDR block. Okay, so this is the formula that is followed. 2 to the power 32 minus x. Here x can be x is equal to 16. It will start from 16 to 32. It can be anything from 16 to 32. Now in our example, it is 16. Okay, so let's use this formula. That is 2 to the power 32 minus x. What is x? It will be equal to 2 to the power 32 minus 16, which is equal to, or let me write it here below, 2 to the power 32 minus 16. That will come to 2 to the power 16. Okay, and if you just check what is 2 to the power 16, you can also calculate in the your calci, then it will be around 65,536. So this is the answer, right? So 2 to the power 16 is equal to 65,536. So this is how you can calculate the number of IPs in a CIDR block. So this is my CIDR block, and this is the calculation I have done here. Same way you can do it for other CIDR blocks as well. Now the reason I'm showing you this is because we will be needing this. Okay, we may need to do the calculation for VPCs. So let's say you have a CIDR block 2 to the power 28. If you have a CIDR slash 28, how do you make the calculations? So again, instead of 16, let me just put it here as 28. That is 32 minus 28, which will be equal to 4. And let me check what is the 2 to the power 2 to the power 4. I think you can take it. 2 power 4 is equal to 16. You can see here the answer will be 16. Okay, and similarly, let's say if you are having some CIDR block like this, if you're not understanding anything, don't worry. We will be seeing how to use the CIDR blocks in VPC. Just focus here. Just see how to calculate the CIDR block because that will be important. So 32 minus 24. What is 32 minus 24? It is equal to 8. So what will be the 2 to the power 8? So 2 to the power 8 is equal to 256. So we will be having totally 256 IP addresses, further IP addresses. So this is how you can do the calculations. Okay, you can refer this. This is how you do the calculation. So this is the rule. Okay, this is the formula. So how do you calculate the number of IPs from a CIDR block? This is the formula that you can use. So let me color this formula as green. So this is the formula that you need to use 2 to the power 32 minus x, and how you can calculate the number of IPs. So anything with the slash 16 will have 65,536 IPs. Anything with slash 28 will have 16 IPs. Anything with slash 24 will have 256 IPs, and so on. Okay, so this is how you can calculate it. So here I have given the explanation. CIDR means classless interdomain range, where a single IP can be subdivided into IP ranges. Okay, and it is represented from a number 0 to 32. Lower the number, higher will be the IP range. Okay, so this is how you can calculate. So it will not be from 0 to 32. It will be from 16 to 32. Let me correct it in the notes, and I'll send you the notes. Okay, so it will have be the lower the number, higher will be the IP range. Okay, so if it is a number 16, IP ranges will be more. If it is a number 32, IP range will be less. What if it is 32? So let's calculate it. So let's say if it is 32, 32, then 32 minus 32, what will be the answer? 0. So 2 to the power 0 is 1. So it will have only one IP. So anything with slash 32 will have a single IP. Okay, so we will be using this slash 32 as well, and I will show you. Okay, so before moving ahead with the APC topic, this is something that we should be aware of, and this is something, some basics of networking that we should be aware of, with that is related to VPC. Okay, so I am done from my side. If you have any questions, then you can please ask, or else we can wrap up the call. All right, then
No,
I
don't.
Yeah, okay. Okay then. I think there are no questions. So we'll wrap up, and we will connect again tomorrow, and we will start a new service, that is VPC, one of the most important service, one of the most prominent service in AWS, that is VPC. Okay, so we will start the topic from tomorrow. Okay then. Thank you. Thank you everyone, and we'll connect tomorrow.